Somebody posted about a bad fuel gauge on the forum and I responded to it. This is generally how these things start. As you can see, having driven around for a while, the needle is no longer pointing all the way up, which means we're no longer looking at conditions where you could say it's in a full open condition or having it fully grounded or things of that nature, those types of electrical wiring problems. Because you could divide these fuel gauge issues into electrical issues with the gauge or the sending unit, it's good to know that somewhere in the middle means that there's some sort of resistance between full open and ground, right? I already know the problem with this unit, and that initial problem that I'd shown is no longer exhibited. But we'll be able to test the gauge or the connections to the gauge to ensure that everything is operating properly, and then go right for the sending unit, which is the culprit. The fact that this sticks when I drive tells me that this is ready for service anyway, and I find these units to be serviceable units. When I say serviceable, I mean within the context of Delorean, and even for that, I think relatively easy, considering that you can hit this unit from just under here by removing the spare tire and then the panel behind it. Here's my setup. I have Phillips screws. Yours may vary. Removing that panel, we could see the fuel pump, and there is the sending unit right there. Then I simply disconnect that harness, and from that harness we'll be able to do some tests within the car to make sure that the gauge is operating correctly from the end of this harness all the way back to the gauge. We now see with the harness disconnected, the needle is pointing straight up in the air because of the open condition. This is what we want to see. That's a good sign. Now we're going to do our short to ground, and we should see it go down to 0. Now I'm going to introduce a shorting cable right here, just a simple wire to connect these two, to give you an idea which two are connected, because they left almost no cable to work here. To see in the back what colors they are, this would be equivalent to the flat bottom portion that would connect here, or in this case, the yellow and black. So this is the flatter side, the bottom, like this. With those two shorted out now, we should have an empty tank. We turn the key. And there we go. While we're here, we could switch from center to top with that shorting cable and test out the dummy light for the low fuel. Seems like a good time to do it. And as our fuel rises in the full open position, we could see that the low fuel indicator is on, so our dummy light is good. If it wasn't on, you might want to check this bulb back here. Sadly, my Heathkit Decade resistor box is down for repairs, but I'm going to get it running just for today. In order to do a quick test, what I'm going to do is find out really quickly here, for the purpose of this test, what the middle resistance is to get half deflection on my fuel gauge, so that others might use it as a reference. So now I've got the Decade box set up for about 80 ohms. It's actually 83. It doesn't really matter. But now we're going to look at the gauge and show what 83 ohms shows on the meter. So at 80 ohms, we're seeing exactly full tank on the gauge, and this will give us a good reference point for full. We know that empty is basically 0, but right now we want to see what full, half, and 0 is. So 80 ohms is what we're going to call full. And here we have 45 ohms of resistance, bringing us right to the halfway point. To achieve 0 on the gauge is actually 8 ohms of resistance. We can now continue with our project to remove this unit. This cap screw just unscrews right off of here. I find that it doesn't come off without a fight if it's been sitting for a while. I've used a pair of channel locks just to give it a nudge and loosen it is my technique. I try not to beat it up though, it's old plastic. And that's all it took, was just a little grab of the channel locks and a twist just to get that loose. And then just to break that tension. And this just unscrews right off of here. No worries at all. Get that off of the cable. And we'll find there's a rubber seal here. We'll slowly lift this out. And there's gasoline in here, right? So as you're lifting it up, the gas is slowly draining out, so don't be in a rush to do this. You can see looking through the side the status of the gasoline drain. Not quick, so like I said, lift it up, wait a while, walk away. Try not to damage this seal right here when removing it too. There's a gasket here, as you see. Let the rest of it drain right into the tank there, that little bit on the bottom. Waste not, want not. When you get to the last portions, you're lifting this out of the tank, it's important that you lift straight out. This is actually two pieces here. I'll show it in just a second. This is where the filter is for this unit. If you lift it out on an angle, this bottom piece will grab and it will fall into the tank. The only effective way to get that is to have to remove the fuel pump. So it's better when pulling this out of the tank, just make sure you come straight up on lifting is the best advice that I could give. Again, not the end of the world. If it falls in, you can still get it, but you gotta pull the pump, or there is a way to fish it out from there. It's not pleasant. So straight up and out. If I'm working on the fuel pump or this, I generally take a piece of aluminum foil, heavy duty aluminum foil, put it over that affected area, and then just snug a cable tie around it. I don't want to get these fumes filling up the whole garage. So me not being in a rush, I'm going to take that bottom cap off, and I'm going to leave this here to sit in the sun on some newspaper and let this fume out for a while. I don't want to bring this right in the house to start working on it and have the whole house smell like gasoline. So my first observations of the bottom filter portion, after drying out, we could see that there's nothing left of this filter element. It's completely broken off from here. This doesn't have any effect on the operation of the unit, of course, although this not working does increase the rate of failure or the chance of failure for the sending unit. I haven't figured out a solution as of yet because this has just been brought to my attention, obviously, right now, as to what I could do to fix this. I don't know if there is a part that I could purchase that could simply snap on as a replacement part for this. I wouldn't want to buy an entire sending unit if only to replace the single portion. So this will have to require some separate thought. But I'm just going to put this off to the side. I just wanted to mention that this was compromised. And here is the unit itself. It is now dried out. And we could see that if I go and turn it in the other direction, we could hear the float go all the way down and subsequently all the way back up in this direction. So just as a first test, we could see that obviously there's nothing seized. And we knew that because, like I said, mine was not stuck in any particular direction. It wasn't stuck in full open or full closed, although that could have also been an indication that a wire was completely separated, as previously mentioned, and that test was done from the harness. It doesn't necessarily mean that an internal component on this unit couldn't have been in the full open position, causing that problem as well. So obviously we're going to do further testing on this. And with a pick, I pull this tab off of the bottom of the unit. Here's where I pull the tab off from. That will in turn allow this cover to come off like so. An inspection inside the unit shows, even though that filter was compromised, I don't see any particulate matter, anything terrible in there. Nothing that would cause any issues. This varies from unit to unit. So in the middle we have the ground post, and there are provisions on the float which we cannot see because they're on the other side, where the float has a means to touch ground to this resistor, this long resistor rod here on the left. And we also have a voltage here coming in on the red wire, and that is completely isolated through this unit all the way to this standoff here, which meets the ground, but it's isolated, right? And this in turn touches a switch here to connect it to ground. I'll tell you right now that in this unit, as I expected, every metal surface was completely covered with an oxide that when I plugged all my cables in to do these tests, I got no reading whatsoever on anything, even after shaking it up and down several times. And what I use for like tube amplifiers and whatnot is deoxit, and it's what I've always used, and I've let it soak for quite a while to break up those oxides, because obviously you can't rip this whole unit apart, but you can spray something in there to dissolve all of that. And this is what I got right now. Right now I am connected to the low gasoline dummy light. I'll also point out that since the bottom cap is not on, these are not aligned properly, so it does take a little bit prodding on my part to get this aligned. But this first switch, it won't really matter. So what I'm going to do is I'm just going to slide this down. We can see that the alarm has gone off. Push it back. And that did not work properly before, no matter how many times I tried. But the deoxit has fixed that. I will show. I got a lot of deoxit in there right now. We could see the contacts on the float that meet this contact over here to short that circuit from black to red. And that's what I cleaned up right there. You could also probably get in there if you needed to with a Q-tip and some Moz or some other type of metal polish if you needed to touch that up. So I'm seeing in its current setting right here, 125 ohms of resistance. Now if I pull this ground off of the edge here and put it right to here, I still see 125 ohms. And that tells me that there is no issue between the edge connector of this cable for ground all the way to here. So I would like to now see where all this extra resistance is coming from. Now obviously it could be coming from the resistor itself, but I think a closer inspection is warranted. And now it's time to look at that resistor from end to end. Given this information with 125, 126 ohms of resistance with the device all the way in the full back position, there you go, it settles down. It moves around based on how hard I slam it to the top. This is not to say that this full top position means what's considered a full gas tank in the car. This is just the full mechanical position of this device. You know, not necessarily where the pump would shut off where you fill your car. However, if your car is like mine, it generally shuts off the pump after it's spilling out the top into your trunk. So, you know, again, your mileage varies. But this is what I'm looking at. However, if I swing all the way to the other direction, we take a look at the low side reading. According to this, my low side reading is 41. And that seems rather strange because my gas gauge works, right? It does work. It does go down to empty. My light turns on, the dummy light turns on, which does make sense, obviously, because the dummy light is by no means connected to the resistor, right? But we're seeing 42, 43 with a gauge that we know goes to 0. But it's already been demonstrated that to get the gauge to actually go to the line of 0 is 8 ohms, which this thing can never produce, at least not here on the test bench. You know, it would make you wonder if having it submerged in gasoline would change these values. And I guess we could look at that too as well. We could reintroduce this back into the tank and have a look at that. I've already done what I needed to do with this, which is remove that heavy layer of oxide that formed on the top of the float, which caused that disconnect between the resistor and the float itself. So now I've put the little key back on to hold everything in place. I see no value in adding this anymore. If I could source one or find a solution for this, I will, but there's no point in putting this on for no reason at all. So I'm just going to forego it for now. Also took the opportunity to spray some deoxit on these contacts before I reinstall the unit. You'll note it is keyed and it only goes in one way. And there's a key over there as well. It shows you what direction that this goes in. Lucky for me, here in Claremont, Florida, we have the greatest hardware store. It just has everything you'd ever need. Jim Willis been in business for like forever. And I was able to get the exact push nut that I needed for this unit. Got it back on. I'm going to secure it real nice when I get home, but we're ready to put this back in the car now. Now we try this again with the new push nut. You can see it goes right in, and we feel it lock into position. It's still pushing up because it's still filling with gas. It'll take just a little bit. Eventually it'll stop being buoyant. I get the screw around the cable, making sure that it's still in the locked position. Hold it there or keep checking. that it doesn't come out of that little lock. Yep, seems okay. I find that a good hand tightening is sufficient. And there you go, it's in. It's back in. Before reconnecting though, I'd like to put my multimeter on there once it fills with gas and take a reading of the resistance and then see how it correlates to the gauge in the car. Shaking the car has an effect on it. I'm waiting for the unit to settle down right now. So finally we're seeing in and around 90 ohms. We're going to hook it up to the car and have a look. We're settling into position, around 90 ohms. Seeing just under full tank. So it looks like everything is working. I'm gonna have to take a measurement again when I get this thing down to half a tank and zero tank. Obviously I'm not gonna just drive around to burn up a tank of gas and include it in the video, but I'll definitely take a note and add it to the notes of this video in the future. So that's my fuel gauge sending unit repair video. Thanks for watching.